We are on concept development of Engage New York, Module 1, Lesson 12. Now, we are using 4 different ways to prove our answer. So we have place value. We're going to use our place value. We are going to use the area model, and we're going to use standard algorithm, and then we have repeated addition. So let's go through. We're going to do problem 1, 3, 5, and then go across to 7, 9, 11. Okay, so those are the problems that we're going to hit right now. So it's either 31 copies of 4 or 4 copies of 31. So how do you guys want to do it? You want to do 4 copies of 31 or 31 copies of 4? Let's try it this way. Here's 31. Here's 31. Here's 31. And here is 31. All right. So now we're going to add these up. We have 1, 2, 3, 4. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's grab these 10 and move 110 over to the hundreds, right? And then we're left with 2. We have 2 left over. These 2 are left over. And now we have 1. So we will have 124. So let's go over here to standard algorithm. 1 times 4 is 4. 4 times 3 is 12. Look at that, 124. Repeated addition. Here's 31 plus 31 plus 31 plus 31. I bet you that would add up to 124. We have 1, 2, 3, 4. And we have 3 times 4 is 12. Then over here, we have 4 copies of 31. Here's 4 times 3 is 12 tens. And 4 times 1 is 4 ones. So it's 4. And 12 tens equals 120. 120 plus 4, 124. Okay? Give me a thumbs up if that seems okay. Let's go ahead and do problem 2 and problem 3 because we're adding a level of difficulty, I guess, if we're adding our decimal. So let's go ahead and do 3 ones. So we're going to have 3.1 and we're going to do it 4 times. Okay? So here's 3. And we're going to do it 4 times. 1, 2, 3, 2. Okay, now let's add it up. 1, 2, 3, 4. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to grab that 10, move it over, and we're left with 2. So here is our 2. Remember, this is a decimal point, and we've moved 110 over there and 110. So we have 110, which is 10 plus 2 plus 0.4, which is going to give us 12.4. Then let's do repeated addition. Now let's think about what we learned, what we thought about again yesterday. If you move the decimal out of the way in order to multiply, in order to do the multiplication, you have essentially multiplied by 10 to get rid of the decimal. So when we get our answer, you have to divide back by 10 and put that decimal back in. So 4 times 1 is 4. 4 times 3 is 12. Now I have to move my decimal back. Here we go. Then if we have 3.1 plus 3.1 plus 3.1 plus 3.1. We'd end up with 1, 2, 3, 4, 4 behind the decimal, and then we'd end up with 12 in front of the decimal. All right. Now let's go ahead and go to our area model. 4 times 3 is 12 ones. And then we have 4 times 1 tenth is 4 tenths. Bring it down, 0.4 plus 12 ones is 12. 12.04 is 12.04. Give me a thumbs up and let me know how you're doing on this concept. All right, now we have 0.31 times 4. So 4 copies of 0.31. Let's do it. So 0.31. Oh, we just have to do, this time we're only simply using the area model and standard algorithm. So let's try it. So 4 times 3 tenths would be 12 tenths. And 4 times 100th would be 4 hundredths. So let's bring that down, and it would be 0.04 plus 12 tenths, and 12 tenths is equal to 1.2. Now, let's add it up, 1.24. Let's come on over here. Let's use our standard algorithm. Let's multiply by 100 and get rid of that decimal. Then we're going to, well, down here, we're going to divide back. So 1 times 4 is 4. 4 times 3 is 12. Now we have to divide by 100, which means we're bringing our decimal back. So we end up with 1.24. Give me a thumbs up. Let me know how you're doing. All right. Problem 5. 11.4 times 4. So we're doing 4 copies of 11.4. That would be one way to do it. And then here is using our area model. 4 times 11 is 44 ones. 4 times 4 is 16 tenths. Now, what does that look like? Let's pull that down and then put it together. So 16 tenths is really 1.6. 44 ones is simply 44. So 44 plus 1.6 is 45.6. Our repeated addition would be 11.4 plus 11.4 plus 11.4 plus 11.4, because multiplication is really repeated addition. Then over here, we can multiply by 10 and get rid of the decimal. And then when we get our answer, we have to divide by 10 to put that decimal back. So 4 times 4 is 16. 4 times 1 is 4 plus 1 is 5. 4 times 1 is 4. And let's put that decimal back. Did we end up with 45.6? Yes, we did. All right, let's jump ahead. Let's go to problem 7, 9, and 11. All right, so this one is getting a little bit bigger on our area model. So 4 times 3 is 12 ones. 4 times 1 tenth is 4 tenths. 4 times 2 is 8 hundredths. Now let's pull it down and add it up. So 8 hundredths would be 0.08. 4 tenths would be 0.4. And 12 ones would simply be 12. So 12 plus, it would be 12.48. Our repeated addition would be 3.12 plus 3.12 plus 3.12 plus 3.12. 4 plus 4, 2 4 times is 8. 1 4 times is 4. 3 4 times is 12. All right, now let's try standard algorithm. Let's move that decimal place. We multiplied it by 100 to get rid of that the decimal. When we come back, we'll divide by 100 in order to put that decimal back. 2 times 4 is 8. 4 times 1 is 4. 4 times 3 is 12. We're going to now put that decimal back, and everything's matching up, correct? How are you guys doing? Okay? All right, so problem 9. 6 copies of 3.42. Let's get started. 6 times 3 is 18 ones. 6 times 4 is 24 tenths. 6 times 2 is 12 hundredths. Okay, I didn't spell that right, but you know what I'm saying. All right, another way to show it would be to go 1 over 10 or 1 over 100, right? All right, 18 ones is 18. 24 tenths would be 2.4. And 12 hundredths, would be 0.12. So now we have to add these up because this guy has to come over, right? To add it up. We have to add this guy to this guy. So now we have 2 plus 0. We have 1 plus 4 is 5. And then we have 18 and 52 hundredths. All right, we could do our repeated addition. 3.42 plus 3.42 plus 3.42 plus 3.42 plus 3.42 plus 3.42. Standard algorithm. Multiply by 100 to move it twice. Divide by 100 to move it back. So 6 times 2 is 12. 6 times 4 is 24 plus 1 is 25. 6 times 3 is 18, 19, 20. Oh, right here, I forgot to add the 2. That's where I caught myself. I caught my mistake. Boy, good thing I did that on the test. That would be a great way to catch yourself if you forgot to add something. Or now we're going to move that decimal back. 20.52. All right. Problem 11. 4 copies of 10.733 thousandths. Put into, so notice how I changed the way I wrote it to make it a little bit, just to have another understanding of what, instead of looking at the word tenths and hundreds and thousands, we're looking at it with a fraction. 4 times 10 is 40 ones. 4 times 7 is 28 tenths. 4 times 3 is 12 hundredths. 4 times 3 is 12 thousandths. Now, we're going to bring that down. Are you guys starting with me? Are you doing it with me? Make sure, don't just sit there. Make sure you are working these problems out with me. So, we're going to bring this down. We're going to say 0.012 plus 0.12 plus 2.8 plus 40. And that is going to equal, now don't let me forget that 2. Okay, so we're going to have 2, 3, 1 plus 2 is 3, 1, hold on, I'm messing up my numbers right now. Oh, I forgot that 9. 9. 1 plus 8 is 9. I forgot a number there. That can happen. It's probably better if I stack them up and add them. And then I have 42. I knew I was forgetting something. All right. Repeated addition, 10.733 plus 10.733 plus 10.733 plus 10.733. So think about that. The answer is 42, and I have 10. I have 10 four times, so it's got to be close. Standard algorithm, 1, 2, 3. So now I multiplied by 1,000 to get rid of that decimal. 3 times 4 is 12. 4 times 3 is 12, 13. 4 times 7 is 28, plus 1 is 29. 4 times 0 is 0 plus 2. 4 times 1 is 4. Now I have to, if I multiplied by 1,000, now I need to divide by that 1,000 and put that decimal back. 42.932. We got it. All right. Let's go ahead and move on to our problem set. Everyone flip over to problem set with me. Okay. So now with problem set, the big idea here is being able to distinguish if there is a reasonable product. Choose the reasonable product. Remember, product is the word answer for each expression. What is the most reasonable? And then explain your reasoning in the space below using words, pictures, or numbers. For example, 2.5 times 4. Well, I know that 25 tenths and if I went 4 times, that would equal 25 times 4 is 100. Then if I went, well, tenths, what would make the most sense? So we could write something like this: 25 tenths times 4 equals 100 tenths. So 100 tenths is 10. Then you could say something about knowing 7 times 3 is 21. So, okay, 21. If I had 7 copies of 3 wholes, that would for sure be 21, right? And because there are 2 numbers behind the decimal, I'm probably going to have 2 numbers behind the decimal. Let's go with, I know the product has to be 3 times 7 plus some more. We have to know, I know the product has to be 3 times 7 plus some more. So the answer has to be 21 plus numbers behind the decimal. Now, because this number has 2 numbers behind the decimal, that means your answer is going to have 2 numbers behind the decimal. So our answer has to be that. So using what I just said as something to think about, how many numbers on part C, how many numbers are behind the decimal? Show me with your fingers. How many numbers are behind the decimal? That's right. There are 3 numbers behind the decimal, right? Okay. Now, 4 times 8 equals what? Sorry, 8 times 6. What is 8 times 6? So, because 8 and 6 are both whole numbers, I know my answer has to at least be 48 as a whole number. Then I have 3 numbers behind the decimal. So which number here has 48 as a whole number with 3 numbers behind the decimal? So let's write it out. So 8 times 6 equals 48. We also know that 8 times 0.22 is going to give us at least 3 numbers behind the decimal. 8 times 2 hundredths, so 8 times 2 hundredths is 16, or 1.6, or 16 hundredths. So if I had 48 plus 0.16, that would be close to, this is close to 48.176, because it'd be 176 versus 16. So I know my answer has to be this one. Next, 9 times 5.48. So let's go back to that same type of reasoning. So I have 9 holes and I have 5 holes. So I know that 9 times 5 is equal to 45, right? And if I had 9 times 48, or 0.48, well, 0.48 is kind of close to 0.50. Well, if you rounded 48 to 0.5, you would know that it would be like 0.45. So what number over here would give us 48 holes, but we have to add some more, because 0.5, 9.5 would give us more, right? Whoops, 9 times, let's change this, 9.5. 9 times 0.95. That would add more to our ones. So if I round to 0.5, 9 times, whoops, I keep doing that, 9.0.5 would equal 4.5. So 45 plus 4.5 equals 49.5. 49.5 is close to 49.32. So 49.32 would be our answer. So that I'm kind of teaching you how to reason out answer. Reason out an answer. Like if you had a guess, you could guess. But if you started using some of these skills of possibly rounding and then adding, you would get really close to and be able to find the answer quickly. All right. Next, on the problem set, we have 3 word problems. On the 3 word problems, you are going to do independently and then we're going to go over them. When you leave, tonight's homework is 187, 188. Those are your 2 pages. And I want you to use the same reasoning that we used on the problem set. So when you're reasoning out the problems, now it's your personal reasoning. So what could you come up with? That's what needs to go here. Not copying exactly what I wrote, but actually reasoning through 2 times 3, 4 times 6, 7 times 6, 9 times 4. What could you come up with to reason out these problems? All right. Problem 2. Here we go. Pedro is building a spice rack with 4 shelves that are each 0.55, 0.55 hundredths meter long. At the hardwood store, Pedro finds that he can only buy the shelving in whole meters. When you go to the hardwood store, they don't let you buy partial meters. You have to buy the whole thing. Exactly how many meters of shelving does he need to buy? And then since he can only buy whole number lengths, how many meters of shelving should he buy? And then explain it. Marcel rides his bike, and the poetry club has its first bake sale. So you're going to complete that and do your best, your personal best, and then we'll come back and check it. All right. So here is my bookshelf or my spice rack with 4 shelves, and they're each 0.55. So if 1 unit is 55 meters, then 4 times that 1 unit is 4 times 0.55. So 4 units is equal to 2.2 meters. But they're not going to let you just come in and buy 2.2 meters. So he needs 2.2 meters to make the shelves, but he has to buy 3 meters of the wood. Now about Marcel. Marcel, the estimation is 1 unit is equal to 3.5 kilometers because we estimated. Now notice my equal signs are wavy. That means estimating. That's like, it's close. So 4 times 1 unit would be 4 times 3.5, which would come to 14 kilometers. And the exact would be 1 unit is equal to 3.62 kilometers. 4 times 3.62 is 14.48 kilometers. So if he's rounding, if he's estimating, it comes to about 14 kilometers per week. He should tell his teacher, though, to be exact, 14.48 kilometers. And finally, $79.35 can be estimated to $80. So if you did $80 times 5, it would come to about $400. So Leslie did not estimate correctly. She went way over, right? So they're only going to make about $400, not close to $4,000. All right. I think we've done a really good job going through our concept development and our problem set. Hopefully you'll be able to go through and do your homework quite easily. I know you will.